So this is the 65th video on Newton's laws of motion. In this video also I'll take up two numerical problems on Newton's laws, miscellaneous questions. Okay. First I'll write down the first question. Okay. Question is this. Consider the diagram shown below in which all details are given. Okay. See, we are given a fixed smooth inclined plane which makes an angle of say 30 degree with the horizontal. Fixed smooth inclined plane which makes an angle of 30 degree with the horizontal. It is a 3D view. There is a smooth straight groove made in this inclined plane. This is the groove. This is line AB. This line AB is horizontal. This is the groove. Okay. A particle is free to move inside this groove. Okay, fine. Now, this groove makes some angle say alpha with this AB. Okay. Now from this groove I draw a straight line parallel to this incline, this line, like this. This is right angle. In 3D view it doesn't appear not very clear. But this is, from this I drop a normal from this point on this. Normal in the sense that this is the inclined plane. I draw a line from this which is normal to this line. Okay. So this distance suppose it is given to be 3 meter, and this distance suppose it is given to be 4 meter. Okay. This is a 3-dimensional view. Okay. This line is normal to this line, parallel to this line, and this line AB horizontal. This is the right angle. Okay. I hope the situation is clear. See, the situation is something like this. This is the inclined plane. This is the groove. Okay, fine. I'll take just another paper. I'll take it. Okay, I'll explain it by diagram. It's something like this. See, this is the inclined plane. Okay, this is the groove AB. Okay, fine. This inclined plane makes an angle of 30 degree. This is angle is 30 degree. And here there is a groove which has been made here. This is the groove. This pen denotes the groove. This is the line AB. This is 30 degree angle. This groove, this is AB. This is the groove. This makes an angle of alpha with this line AB. And from this I drop a normal on this. This is 3 meter and this is 4 meter. I suppose it is clear. Fine. See. Now it is frictionless, there is no friction anywhere. An object is released from rest from this point on the groove. Okay. Now we have been asked to find the speed of the particle when it reaches this point A. We take g to be 10 meter per second square. This is the value of g. This is the object which has been released from this point of the groove. It moves along this smooth groove and reaches point A. It has been released from rest. The question is find the speed of this point when this reaches point A. Okay. So now what should be our approach? See, our approach should be this. What we must do, we must first draw the free body of this particle sliding along the groove with respect to ground. From that free body, we find its acceleration with respect to ground. In most probably that acceleration will come out to be constant. We then apply the formula for straight line motion along constant acceleration v square equal to u square plus 2ad. And from that we will get the value of v. Okay. Alright. So now, first what I do, I draw the free body of this particle with respect to the ground. So what I'll do, I'll slightly rub it, okay? I'll just draw it, not rub it, I'll draw it here. So see, this is the inclined plane. This is the groove, particle is sliding around this groove, okay? At some instant, particle has come here. At that instant, I draw its free body. See, there is one weight mg. M is the mass of the particle, okay? Now, there will be two normal forces acting on this particle due to the groove. First normal force will be something like this, N1, which will be perpendicular to this plane of motion. And there will be another normal force, N2, which will be normal to this wall of the groove. I suppose it is clear what I am saying. What I am saying is this. See, this is the inclined plane AB. This is the inclined plane, this is the inclined plane. This is the groove, okay? Object is sliding along this groove, object is somewhere here. Then which forces? A force mg will act in downward direction, its weight. Now one normal reaction N1 will exert this plane of the groove will exert normal force N1 like this. And a groove is something like this. So groove will exert a normal force N2 like this. I hope it is clear what I am saying. So what are the forces on this particle with respect to ground? A weight mg in downward direction. Okay. Then this plane of the inclined plane will exert a force N1 like this. And this groove is something like this. Groove will exert a force N2 on particle in this direction. So these are the three forces. Fine. Now this M1G, this angle is 30 degree. So let us call this as theta say. Okay. So mg will have a component of mg cos theta in normal to this plane, which will just balance N1. So N1 will just be equal to mg cos theta. That is N1. Okay. Now mg also has a component along the inclined plane parallel to this line. That is simply mg sin theta. Okay. Now see, this is a right angle triangle. This is 3 meter, this is 4 meter. So tan alpha becomes 3 by 4 from geometry. Alright. Tan alpha is how much? 3 by 4. So this angle is alpha. Okay. Fine. Alright. See, at some instant particle is somewhere here. Mg sin alpha is in this direction. Mg sin theta, sorry. Now this mg sin theta is parallel to this line. So this is 90 degree, this angle is also 90 degree. It is in 3D view, so don't get confused with the diagram. This is 90 degree, this is alpha. So this angle becomes how much? 90 degree minus alpha it becomes. Okay. So mg, component of mg along the groove becomes mg sin theta cos 90 minus alpha. So component of mg sin theta along the groove is component of mg sin theta along the groove is mg sin theta cos of 90 minus alpha, which is simply mg sin theta sin alpha. Now there is one more force N2 on this particle, which is the vertical face of this groove exerts. Okay. Now this N2 will just cancel the component of mg sin theta normal to this groove. That is mg sin theta sin 90 minus alpha. I suppose it is clear what I am saying. See, again I will take the help of this paper. This is the inclined plane. Okay. This is the groove. Particle is somewhere here. Mg is acting downward. N1 is like this, which just balances mg cos theta. And N2 is like this. Okay. Now component of mg along this incline is mg sin theta in this direction. Component of mg sin theta along this groove is mg sin theta sin alpha. Component of mg sin theta normal to groove is mg sin theta cos alpha, which just balances N2. Okay. So N2 just becomes how much? N2 becomes mg sin theta sin 90 minus alpha, which is simply mg sin theta cos alpha. These are the various forces acting. Okay. See, there is no friction at all. So net force on the particle along the groove is mg sin theta sin alpha. So acceleration of particle with respect to ground is simply from Newton's second law, m into a, where mg sin theta sin alpha is the net force on particle along the groove, that is equal to ma. So acceleration of block with respect to ground is simply g sin theta sin alpha. Okay. Now g is how much? 10. Theta is how much? Theta is 30 degrees. Sin theta becomes sin 30 degree 1 by 2 into sin alpha. How much is tan alpha? 3 by 4. So from trigonometry, sin alpha becomes 3 by 5. So sin alpha becomes what? 3 by 5. Now 5 into 2, 10 cancels out. 3 meter per second square, which is a constant quantity. So the particle moves along the groove at a constant acceleration of 3 meter per second square. Alright, fine. Now we have been asked to find the speed of the particle when it reaches this at this point, lowest point of the groove. Okay. Now I write up this one. Since acceleration is constant and it is moving along a straight line, so from the formula for motion along straight line with constant acceleration, v square is equal to u square plus 2ad. V square, u is just 0 starting from rest, plus 2a into d. U is 0, initial speed u is 0, u square 0 square. 2, a becomes how much? 3. And d, what is d? Net displacement of particle when it moves from here to here, which is simply this distance. Now this you can see from right angle triangle, this is 3, this is 4. So d becomes root 3 square plus 4 square, that is simply 5 meters. This d I substitute here. So 2 into 3 into 5, okay. 6 into 5, 30. So v square becomes 30 meter per second whole square. So v becomes square root of this quantity. Fine. Now I write this one. Okay. So this means v becomes root 30 meter per second. This is therefore the answer to the required question. Okay, fine. Alright. So this is the answer to the first part of the question. Okay. So first question has been fully solved. Alright. Now I love this one. Now I take up another example. Second example is this. See, there are two fixed inclined planes. Two fixed smooth inclined planes, each of which makes an angle of alpha with the horizontal as shown. Here there is a cylinder, uniform solid cylinder of mass m. Okay. And here there is a wedge with vertical face. This one. This mass of the wedge is 2m. This wedge is free to slide along a smooth inclined plane, which also makes an angle of alpha with the horizontal. Okay. So these are two fixed smooth inclined planes. Each of the inclined plane makes an angle of alpha with the horizontal. There is a uniform solid cylinder of mass m. This is a wedge of mass 2m with vertical face. There is no friction anywhere. All the bodies are rigid. System is released from rest. No friction anywhere. I am repeating again and again. System is released from rest. Question is, find the normal force between M cylinder and the wedge when the system is released from rest. Find the normal force between normal force between the cylinder and the wedge after the system is released from rest. After these two bodies are released from rest. Okay, but the wedges are fixed. Wedges don't move. Only cylinder and the wedge. This wedge moves. These two inclined planes are fixed. Okay. So now how to proceed? So what we will do first? We will draw the free body of cylinder and wedge separately with respect to ground. Okay. So I draw the free body of the cylinder. Okay. So I draw the free body of cylinder on this here. So this is the cylinder C. This is the wedge. Okay. So what is the free body of cylinder? What are forces acting? Only real forces will act because we are observing the cylinder from ground frame. mg. This wedge exerts a normal force N1 like this, which is normal to this incline of the inclined face. And this wedge exerts a normal force N on the cylinder in leftward direction. So these are the only three forces acting on the cylinder. Alright. Now what I do, I draw the free body of this wedge, again with respect to ground. So only real forces will act on it. So this is 2m. So this is a weight 2mg. This is normal force N2. This inclined plane exerts in this direction. And by Newton's third law, this cylinder exerts normal force N on the wedge in rightward direction. This is the free body of the wedge. This is the free body of cylinder. Both the free bodies are with respect to ground frame. Now what we have to do, we have to show the accelerations. Okay. Now let us assume the acceleration direction arbitrarily. Suppose that I show the acceleration direction of this, say A1 in downward direction, ground with respect to ground. If this moves down, then this has to move up. A2. A2 is acceleration of cylinder with respect to ground. A1 is acceleration of wedge with respect to ground. Okay. Both of them have been assumed arbitrarily. We can show A1 up the incline also. We can show A2 down the incline also. All four combinations you can show. There is no problem. Because when there is no friction, you can always assume the motion direction in an arbitrary manner. Alright, fine. So now all the accelerations have been shown. Now what I do, I apply Newton's second law to cylinder with respect to ground up the incline. Okay. So if I draw this line parallel to this, then this angle becomes alpha. Okay. So apply Newton's second law to this cylinder with respect to ground up the incline. Alright. So what do I write? N cos alpha minus mg sin alpha. N cos alpha minus mg sin alpha is equals to m times A2. This is the first equation. A2 is the acceleration of cylinder with respect to ground. Okay. Now what I do, I apply Newton's second law to wedge with respect to ground up the incline. Now this n is this, and this angle is alpha. If I draw a parallel, this angle also becomes alpha. So apply Newton's second law to wedge with respect to ground up the incline, direction which I have shown it to accelerate. So sorry, down the incline, because I have shown it to accelerate downward. Now what I'll write here? 2mg sin alpha, component of 2mg in this direction. 2mg sin alpha minus n cos alpha is equal to 2ma1. Okay, fine, alright. So n cos alpha minus mg sin alpha equal to ma2. 2mg sin alpha minus n cos alpha is equal to 2ma1. Alright, fine. Now see, now count the number of unknowns. A1, A2, n. Three unknowns are there. So we need three equations. Two equations we have already obtained from Newton's second law. Now we need one more equation. We need the relationship between A1 and A2. That is geometrical constraint relation. Now, to find the relation between A1 and A2, what we have to do? And first I'll rub this, okay? See, I draw these two bodies here again. This is a cylinder, okay? This is the wedge, vertical face of the wedge, which are both in contact. These are the two material points of cylinder and wedge which are in contact, okay? This is the common normal at the contact point. Okay. Now this cylinder is a translating cylinder. All the material points of cylinder have the same acceleration. So this point of cylinder also has acceleration equal to say a2. Alright. And this point of wedge also has acceleration equal to that of a1. In this way. This angle is alpha. This angle is also alpha. Okay. And a2 is, this angle is also alpha. These are the two material points. This is a point say P2 and this is a point say P1. P1 is the material point of wedge and P2 is the material point of cylinder, which are both in contact. Acceleration of P1 with respect to ground is a1 down the incline. Acceleration of P2 with respect to ground is a2 up the incline. Now see, both the cylinder and the wedge are translating. They are moving without any rotation. P1, P2 are the two respective points of these two bodies which are in mutual contact. Both the solid bodies, both the bodies are rigid. So both the bodies are rigid, both are in mutual contact, and they are non-rotating bodies, translating bodies. So in view of these three reasons, component of acceleration of P1 and P2 along common normal is equal. Component of acceleration of P1 and P2 along common normal will be equal in magnitude and direction both. Alright. So component of A2 along this direction becomes A2 cos alpha. That is same as component of A1 in this direction. Component of A1 in this direction. Okay. How much will that be? A1, this is also A1. Alright, fine. This is A2, this is alpha. This is A1. Okay, A1. This angle is also what? Alpha. Alright. So this becomes, I hope it is clear. See, A2 is this. This is a parallel line, this angle is alpha. A1 is this. This is a parallel line, this angle is also alpha. This is a common normal. So A2 cos alpha is equal to A1 cos alpha. That meaning A1 equal to A2. This is the third relation. I hope it is absolutely clear. Fine. So we get what? We get A2 cos alpha is equal to A1 cos alpha. Alright. This is a common normal. So from this it follows that A1 is equal to A2. Alright. Now simply what we'll do, we'll find A1, A2 and substitute in this equation, third equation. From this you can see what is A1. We divide this equation by 2m, we get A1. If we divide this equation by 2m, what do we get? G sin alpha minus n by 2m into cos alpha. This is just A1. And A2 is what? I divide this equation by m, I get A2. How do we get? N cos alpha by m minus what? G sin alpha. Alright, fine. Now rub this one. Now I bring n on one side, n cos this side, take one side, okay? So it becomes n by m cos alpha, okay? This becomes 1 by 2 plus 1 is equal to 2g sin alpha. Fine. How much it becomes? N becomes n by m into cos alpha into 3 by 2 2g sin alpha. Alright. So n becomes 4 mg by 3. 2m goes that side. 4 mg by 3. Sin by cos becomes tan. Is therefore the required answer to this problem. Okay. So n becomes how much? 4 mg by 3 tan alpha. This is therefore the required answer. Alright. So 2 into m into 2m by 3m. Okay, yes, fine. So n becomes 4 mg by 3 tan alpha question. Okay, this is the required answer. So I hope you have fully understood these two problems. Okay. In case you have some, you go through these problems properly. If you have some doubt, write it in the comment box. I will explain it, clarify it. Okay. This problem also I have taken. This problem is from Krotov. Okay, it was Krotov book, Russian book, na? Good numericals are there. So Krotov book I have taken this numerical. Okay. So I close it here. Fine. All right.